This is Scott Sims going over Project 5, pulling temperature and humidity data. For my design, I'm actually pulling the weather data from an open source API known as Weather API, and I've coded it here such that I get I call the API every 1 hour, so I'm not exhausting my resources. I forget what the allocation limit is for Weather API and how many calls you can make, but 1 hour is enough. Also, because the API is being made over Wi-Fi, we have to provide our Wi-Fi credentials, both the SSID, the ID of the network you're connecting to, and the password. My wiring, which I haven't shown yet, I'm going to be displaying the weather data on a small OLED screen, so we have to set up the display for the OLED screen, and I'll show how that's wired up in a second. And then from there, it's actually just initializing all of our constants for the display, our API key. I'm currently in Zurich, so I'm going to pull weather data from Zurich. And then using those global constants, we construct the API endpoint. And we can see here that this is the endpoint that Weather API expects for you to call with embedding the API key. In order to get this API key, you have to create an account online with them, and then it'll generate an API key for you so that you can make the call to the API endpoint. And then I'm embedding the city for which I live in this endpoint, so it will pull from my city. And then we can see this extra query param of AQI here set to no, and that's just for the air quality index. It already returns enough data from this endpoint that we don't need to pull this extra data as well. I allowed the units to be configurable, metric or imperial. And since I'm here in Europe, I'll just stick with metric as that's what they go with. I have here a prototype for a get weather data function. That's down below. I have to forward declare it because it's referenced before its actual definition, so we'll see what that looks like in a second. After that, going through the setup function here, it's more or less just setting up the display and setting up the Wi-Fi. So we make sure that we can actually allocate resources for the display, and then we just we clear it, and then we set it to initializing so that we know that it's working. And then from there, we will display that we're connecting to Wi-Fi on the display, so we're up to date on what's happening there. And I believe while the while the OLED display is connected, you can actually see what's coming over the serial. So even though I'm setting up serial, I don't think you can actually do the serial monitor while the display is going. Or at least I wasn't able to. So that's why I'm also displaying to the OLED so I can monitor what's happening, because I can't do it over serial. From there, we just wait for Wi-Fi to be connected. Again, this will be displayed on the OLED display itself. And then before we leave the setup, we get the initial call to get weather data. And that's because in the loop method here, the one that forever loops while the board is powered, we don't actually get the next weather data until the 1 hour time has elapsed. So if we don't call that initial one, we have to actually wait an hour before the first weather is captured. In this get weather function here, we can see that we're just using our Wi-Fi client that we've already established when we connected the Wi-Fi, and an HTTP client to make a simple HTTP 1.1 request to the API endpoint. And again, this is just the endpoint that we constructed here with our API key and the city that we want to make a request to. So we make a request using our client and the API endpoint, which then returns a response from the API with all the data that we need. If we go down here, the return format is in JSON, as most APIs are. So we deserialize the JSON payload, and then we extract the data that we want from it. We can actually look and see what the data looks like using the API Explorer from Weather API. Let me switch over to that real quick. So here, using their API Explorer, we can see what a response looks like to their API. You get your typical response headers, but we don't need anything from there. It's mostly the response body that we're interested in of the JSON, and we're just confirming that we get Zurich, Switzerland, our latitude or longitude, but we also want to make sure that we're extracting out from the current for current temperature, the temp C. I'm pulling both temp C and temp F because I gave the ability to configure for imperial or metric. And then we also wanted the humidity as well. So those are the main things that we're focusing on in the JSON response body here. So if we go back to the code, we can see here that here from the current member of the JSON, I'm pulling out the temp field, the temp C field, the humidity, just confirming the city name and the country location as well too. So printing all that data to across the serial monitor if the OLED screen's not hooked up, but then also it will be displayed on the OLED screen as well too. So here in this update display, we're passing in the temperature, the humidity, the location, and the units, and then we're just calling the display API to make sure all the text and everything is displayed on the OLED screen. So that's the code. It's pretty simple, nothing too hard there. If we go and look and see how we have this wired up, I'll try my best to get this in here. We have the ESP8266 here, where because the width of the board is also the same width as the inner rows of the breadboard, what I've had to do is actually run some extender cables from underneath it, because it runs parallel on the breadboard here, to reach out so that I can actually run these jumper wires to the proper connections. So all that we have here is this orange is running from the ground pin on the 8266, which is kind of hard to see here. But this is going to be ground, the orange, and then I have a gray here that's running from D1, which is the clock line, and the blue here is running to D2, which is the data line. And then just up here on the red line, this is the 3.3 volts. And then so if we look at the OLED screen, this white one is just jumpered from the 3.3 volts, and that's running into the VCC pin of the OLED screen. Ground is running to ground, which is just the green here. Yellow is the clock line. This is running to D1 for the clock. And then black here is running to D2, which is the data. And it's a pretty simple wire up, no resistors or capacitors needed, just straight plug and play. And if I plug this in, and I want to mostly focus on the OLED, and I guess I can show an overview of everything here to make it a little bit easier to see. But again, red is 3.3 volts running to the VCC of the OLED screen. Gray is D1, the data line, or the clock line, sorry. Blue is D2, the data line, and orange is ground, running to ground on the OLED screen here. So let's focus mostly on the OLED screen here. I wonder if I can get it a little bit tighter on this. Nope. If you remember in the code, I have it when the first setup function and it's connecting to Wi-Fi, it'll show that's connecting to Wi-Fi and then before displaying any weather data. So once I plug this in, we'll see that it's initializing and then showing that it's connecting to Wi-Fi. And then now we're getting our weather data. So right now we can see in Zurich it's 10.2 degrees Celsius and 82% humidity, which 10.2 is probably what, 50 degrees Fahrenheit right now. Yeah, so that is pulling weather data from an open source API and rendering on an OLED screen using the ESP8266.